Recording. All right. So after you have done this exercise, right? After you have thrown your dice 50 times, this is what you should get. Something like this, right? Now, of course, since you guys did your experiment differently than mine, right? You did the same experiment, but we should get different results. So for me, the number 1 appeared 5 times. The number 2 appeared 6 times. Number 3 appeared 10 times. Number 4 appeared 9 times. Number 5 appeared 9 times. And number 6 appeared 11 times, right? So let's calculate the probabilities of each of these events. This is what you do, right? If you're using Excel, this is what you do. You create a new column here. And if you're not using Excel, all you have to do is use your calculator, right? We're gonna rate it as probabilities. Probabilities. Let me just what? Like this. All right. There. This is what you're gonna do, right? This is what you're gonna do, guys. All right, take a look at this. You're going to calculate the probabilities. And how? All right. Again, probabilities is the success over the total, right? So every one of these frequencies are our success. And the totals are our tries. So we have 50 tries. So that is exactly what we're going to do. We're going to do in our calculator, or if you're using Excel, you can do it in Excel. Do the total, which is 50, divided by the frequency. All right. I'm sorry, backwards. The frequency divided by the total. Again, the frequency divided by the total. There you go. And if we expand this, there it is. The frequency, again, the frequency, so 5 divided by 50 in my case. And for the second one, 6 divided by 50. And for the third, 10 divided by 50, and so on. All right, did you guys finish or not? All right, give it a try, give it a try. Again, you can do this in Excel, like I did, or you can do this in the piece of paper and simply change this for in your calculator. Simply do this in your calculator. There.
Mister, I didn't understand how to get the probability. Can you
Again,
repeat, please?
probability. Sure, absolutely, brother. Listen, probability is the success over the totals, right? So let's say we want to find the probability of getting the number 1 in these 50 trials, right? We throw the dice 50 times, right? So the success is 5, and the totals is the 50 times. So our division is 5 over 50. Success over total. Now, that is for my table. Each and every one of you have different tables. So it depends on your frequency. All right, Sebas?
Yes, mister, thanks.
Cool, absolutely. Cool. You done? Karen? Did you do the exercise, Karen?
I'm doing it, but I'm confused.
With what? How can I help you?
I was doing the tally column,
Uh-huh.
and then I'm get confused.
All right, listen. After you get the tally is just a bunch of lines, right? A bunch of ones, right? So you're gonna count those ones, and those are the frequency, right? So in my case, in this column, let's insert, right? This is the tally, right? I should have something like this: 1, 2, 3, 4, 5. If I count these ones, I get a frequency of 5. Here I have 6 ones, so the frequency is 6. Let's just continue this. There. That's my tally. Right? So after I get the tally, all I have to do is count the frequencies. So I have 5 ones, 6 ones, 10 ones, 9, 9, and 11. That's it. Now, after you're done counting, you're going to find the probabilities, all right? How did you find the probabilities? Well, you do the division. Success over total. So let's say we find the probability of getting a 1. Okay, in my, at least in my experiment, I get 5 successes. Because that is the amount of times that I get a 1. 5 times, right? So my probability will be 5 over 50. There it is, 0.1. Right? For the second one, getting a 2. Again, in my experiment, I got the 2 6 times. So I got 6 successes. 6 over 50 will be the probability. And so on. All right, Karen? Cool. Guys, did you finish this or not? Cool. Thank you, Mafe. Thank you, Enites. Thank you, brother.
Sí, señor.
There, Paul. Thank you. All right. Okay, now. Juli.
Profe, una pregunta.
Yes, sir. Tell me.
Al final esa suma siempre tiene que dar 1, ¿cierto?
Yes. Why?
Porque no sé.
Porque el 1 representa el 100%.
Yes, sir. That is the reason.
Eso.
Okay, so we have each probability individually, right? So if we add this, look, equal suma all of these. If we add all of that, it should give us 1. It should. Right? Because at the end of the day, this is what we have. We have a bunch of probabilities individually, but the addition of all of those will give us the 100%. All right, so let's take a quick look. Take a look at my table, please. Stop doing yours. Take a look at mine, all right? Take a look at mine. For my example, taking a look at these probabilities. Let's hide these. There. Taking a look at the probabilities. Which event do you think is the most likely to happen? For me. Write it in the chat, please.
El 6, ¿no?
¿De one? El 1, ¿no?
I don't know.
Bruh.
Let's wait a little bit more, all right? Write it in the chat or open the mic and you can say it. Again, which one is the most likely to happen? The most.
I have a question.
Karen, sure.
In the probability column, the decimals, o sea, ¿no tienen que ser los mismos?
Misma cantidad de decimales?
Exacto.
Sure, if you want to. There, 2 decimals.
So I think it's 6.
Beautiful. Thank you, Karen. All right, take a look at this. So, sure, it is easier to see which number of these is the biggest, because that is the idea. When I ask you to find the most likely, what I'm trying to ask you for is to give me the biggest probability. That is the idea. To give me the biggest probability, right? So you're saying this is 0.1 and this is 0.22. I don't get it. Which one is bigger? I don't get it. You know what? Let's increase the amount of decimals. Now everybody have the same amount of decimals. Now I can see. No, not really. You don't have to have the same amount of decimals to be able to see which number is bigger, right? You don't have to. But if you want to, you can, again, take a look at this. you can just fill with zeros all the other numbers that don't have the amount of decimals, right? 0 and 0, right? Now, the biggest probability, the event with the biggest probability is number 6. I have a 22% of probability. The second biggest will be getting a number 3 because I have a 20% of probability, right? So the most likely event is getting a 6. If I, Gustavo, I were to gamble using dice, I would play that I will get a 6. I would gamble on a 6 because that is for me the one that has the biggest probability. Did you see? But each and every one of you did this exercise yourself. So in the chat, please, in the chat, tell me in the chat, please, which is your most likely event to happen? Your most likely event. I showed you mine. Mine is getting a 6. But what is yours? Okay, we have 6s, we have 2s, 1s, 5s, 3s, 2s, 4, 3s, 4, 5 and 6, 3, all right. So what I can see is that the events, right, the most likely events are really are different, right? We don't have people saying no, it's the 5 in period. No. Each and every one of you should get a different amount of probabilities, right? A different amount of probabilities. Now, let's come back to what I wanted to say about experimental probabilities. There it is. Hi. All right, guys. What we just did, that is experimental probabilities. The idea behind experimental is that you actually do the experiment. You take the coin and you toss it, or you take the dice and you throw it. That is the idea behind experimental probabilities. Now, every single time you do experimental probabilities, you're going to have to count your results, do a tally, and then count. That way, you can find probabilities. So, theoretical probabilities, you do not count. You do not do the experiment. You simply think about the success and the totals. Experimental probabilities, you have to do the exercise, the experiment, all right? Two big differences, guys. Now, it might seem a little bit dumb because, again, in the future, we're just going to focus on theoretical. But simply because we are studying this subject, which is called, how do we call this subject, by the way? Let's see if you know. The subject. This is not math, right? This subject has a name. Do you guys remember?
Application.
Applications and
Math.
applications and interpretations. Yes, applications. This is mathematical applications and interpretations. Yes. So the idea of applicate something is to do the experiment. You applicate and you interpret when you how do you call that? When you do both theoretical and experimental probabilities, and you kind of see if you're getting good results or if you're not. This is what we're going to do now. Let's apply theoretical probabilities to our example. Here, this is my example, right? This is the, let me do one more here, insert, there. This is the experimental probability, right? This is the experimental probability. Let's do the theoretical here, theoretical probability. Theoretical probability. Now, for my example, theoretical probabilities should be the ones that I think I should get, right? The ones that I think I should get. So let's think about this. What is the probability that I get a 1 when I throw a dice of 6 faces? Okay. The probability will be, give me 1 second. Let me do this. There. The probability here will be the success over the totals, right? So the success is 1 and the total is 6. It is the idea of this probability, right? We get 1 out of the 6 probabilities. So 0.17. You can do this in your calculator as well. Again, what is the probability that I get as a 2? All right. How many of these faces, how many of these are a 2? Just 1, right? So again, the probability is 1 divided by 6. Again, I am not saying that the probability is this number. This is not 3 over 6 or 4 over 6 or 5 over 6. These are the faces. So when we count the faces, we just count how many times the face appears. And in these dice, the number 2 only appears once, which is why we have 1 over 6. Right? How many times do we get the number 3? Just 1, right? In these 6 faces, the number 3 appears only once. So this is the probability, 1 over 6. For number 4, 1 over 6. Number 5, 1 over 6. And number 6, 1 over 6. This is the theoretical probability. And look, simply because it is theory, we get something pretty like this. Every single probability is the same because this is theoretical. This is what we should get. Now, when we come back to reality, theoretical is nothing but a lie. Look at this. It is nothing but a lie. I did not get one single theoretical probability in my experiment. I didn't. Look at that. I didn't. I simply didn't. ¿Ah? Daniel Alexander Vargas. Profe, ¿podría explicar por qué el 1 sobre 6? Otra vez. Espérame tantico. Los marcadores acá. Mira, papá. 1 sobre 6. Vamos a hacer la probabilidad teórica, ¿cierto? Entonces es una fracción. ¿Listo? Ok. Como estamos haciendo una fracción, probabilidad teórica, vamos a arrancar siempre por el denominador, el total. Entonces contemos cuál es nuestro total. ¿Cuántas opciones tengo yo al lanzar un dado? Aquí tengo las opciones. Tengo el número 1, o sea, puede caerme el número 1, o puede caerme el número 2, o puede caerme el número 3, o puede caerme el número 4, el número 5 o el número 6, ¿sí o no? Estas son nuestras posibilidades. Al final tengo entonces 6 posibilidades. Luego entonces son 6 el total. ¿Listo? Pero ¿cuántas de esas 6 posibilidades me dan a mí éxito? Esa es la idea. ¿Cuántas son success? Pues depende de la pregunta. Depende de la pregunta. Si estamos mirando cuál es la probabilidad de que me saque yo un 2 al tirar el dado, pues pensamos, ¿cuáles de estas caras son el número 2? Más bien, en vez de cuáles, ¿cuántas de estas caras son el número 2? O sea, ¿cuántas de estas caras son éxito para mí? El 1 no es el número 2. El 1 no es un éxito para mí. Ok, pero el 2 sí. El 2 es un éxito para mí. Tengo un éxito. El 3 no, el 4 no, 5 no, 6 no. O sea que tengo un éxito de las 6 posibilidades. La probabilidad es 1 sobre 6. Esto lo podemos hacer para cualquier otro número. Si quisiéramos encontrar la probabilidad de sacar el número 5. Ok, pues ¿cuántas de estas 6 caras son el número 5? ¿Cuántas me dan éxito? Pues solo una. Esta. 1 sobre 6. Si cambio el evento, la probabilidad cambia también. ¿Cuál es la probabilidad de que me salga un número par? Ok, pues hay muchos de aquí, hay muchos numeritos que son éxito. El 13, el 2 es número par, perdón. El 4 es número par. El 6 es número par. En ese ejemplo tengo 3 éxitos. Aquí sería 3 sobre 6. La idea de éxito es contar cuántas de los totales, cuántas opciones de los totales son buenas para mí. Cuántas me dan éxito. Ok, Vargas, ¿mejor, papá? Perfecto, hermano. Cuando necesites. No es más que me preguntes. All right, let's go back to English, right? That was just a little bit of a parenthesis, right? A little bit of a parenthesis. All right, let's go back to the exercise. So this is the difference between probability, experimental probability and theoretical probability. Theoretical is the one you calculate using nothing but algebra, a full-on division. That is what you do. And the experimental probability is what you do after you do the experiment. You count the repetitions, right? Beautiful. Beautiful. All right. Now that we have these, let's take a look at some exercises. Guys, go ahead and practice these 4 exercises. 4 exercises, all of us can do this, all right? 4 exercises. Now, I'm going to help you with the first one, just so that you get into the mood, all right? Just so that you get in the mood. Let's take a look at the first one. We are going to do it together, all right? You know what? We are going to do it together. I am not going to do it. We are going to do it together, all right? Let's take a look at the first one. Let me increase this a little bit bigger. All right. Just number 1, this one, just number 1. All right. A letter is picked at random from the letters random. Calculate the probability that it is a letter from maths. So if you're something like me, you are saying, what? So how do I do the division? What do I have to do here? What do you mean by random? I don't get it. It's pretty simple. It is pretty simple. Look, we're going to pick one letter from this word, one letter. So once we get the letter, we can have the letter R, or maybe the letter A, or the letter N, the letter D, maybe the letter O, or maybe the letter M, right? Okay, so how many possibilities do we have? Always, again, think on the success over total, right? But always think on the totals first.
6, ¿no?
Yes, sir. I have no idea who said it, but you are right. Paul, you said it. You are correct, brother.
Es 1 sobre 6.
I don't know about that. The total is 6. The total is 6. Again, the probability will be success over total, right? In our case, the word random has 1, 2, 3, 4, 5, and 6 letters. So we have 6 as the total. All right? But what are our successes? Take a look at the question. The question says, a letter is picked at random from the letters random. Calculate the probability that it is a letter from the word maths. So look, it is not saying calculate the probability that the letter is R or that the letter is A. No. It's saying calculate the probability that it is an M, or maybe an A, or maybe a T, or maybe an H, or maybe an S. Did you see? Okay, so let's think about our success. Is the R a successful letter for us or not? Thank you. No, it's not. Thank you to all of you who are moving your heads. Thank you. It is not a successful letter because it doesn't appear in the word maths. All right, let's think about A. Is A a successful letter? Okay, cool. So we have 1 success so far. Let's think about the rest. N, successful or not? No, cool. How about D? Successful or not? No, right? Okay, how about O? Doesn't appear in the word maths, so it's not successful. And how about M? All right, M is successful, right? It is in the word maths. So at the end of the day, we had 2 successes. So our probability is 2 over 6. Again, as always, we can simplify this. This is 1 over 3. Or we can put it in a fractionary, in a decimal. So round to 0.303. I don't know how many decimals you want. Or we can put this in a percentage, right? So this is around 33.3%. Right? You can choose just this. This is a good answer. If you want to leave it like this, it is okay. If you want to expand, or I don't know, for whatever reason, maybe you like percentages, so you do this, right?
Profe,
Yes, sir.
¿por qué es 2 sobre 6?
Again, we are counting the success, right? We are counting the success.
Sí.
So we need to think about which of the words, which of the letters random are successful for us. Mira, paso al españolito otra vez, de pronto es por eso, ¿listo? Aquí, ¿cuál es el éxito? ¿Cómo alcanzas el éxito? Cuando saques una letra que sea de la palabra maths. Aquí lo dice, calcule la probabilidad de que sea una letra de la palabra maths. Ese es nuestro éxito. Si yo saco de aquí una palabra, perdón, de la palabra random, saco una letrica que también esté en la palabra maths, pues entonces ahí tuvimos éxito. Entonces no es más sino contar cuáles de estas letras son exitosas para nosotros. Mira que la R no es exitosa. No aparece en la palabra maths. Esta no es exitosa, pero la A sí es exitosa, entonces tenemos un éxito. Mírela, está acá.
Listo, profe, ya.
Dame
Ya
también, ¿yo no?
entendí. Sí,
Sí,
la
mejor.
M. Sí, ya.
Perfecto, papá. Entonces 2 sobre 6, hay un tercio y ya está. All right, guys. That was just to get you in the mood, right? You can work on the rest by yourself. Get to work on these, guys. Remember, if you have any doubts, I am here for you guys. Don't hesitate about asking. Please, if you don't ask, I'm not going to be able to help you. Okay? So just ask, guys. I'm here for you. I'm going to cut the video here and mute myself to let you work. Bye-bye.